Hello everyone, welcome to another video of Advanced Mathematics of class 9, and today we are going to start a new chapter, that is chapter 6, which is the sequence and series. Now very easy chapter, not that hard. So there are a lot of sums in this chapter, but the exercise that we will be doing today is exercise 6.1, which is very easy. So what are the things that you need to know? What is a series or a sequence? Series or a sequence means a series of numbers that you put out and they have some sort of relationship within them. For example, if I write this series 1, 3, 5, 7, 9, 11, 13 and it goes on. This series has a relation that all are odd numbers and the difference between each of the two numbers is actually 2. 3 minus 1 is 2, difference between these two is 2. So keep on adding 2 and you get the next number, right? So there is a relation between every two numbers here and you can write a general term for this. What do you mean by general term? Suppose I write a general term like twice n minus 1, where n is the number of the or the position of the number. For example, in the third position, here these are called terms, T-E-R-M-S, terms in a series. So this is the first term, second term, third, fourth, fifth, sixth, seventh, and it goes on. So if I write twice n plus 1, where n is the term, number of terms. So for the nth term, this can go on to up to nth term, means any term up to a certain number. N is a natural number. So what will be the nth term? The nth term will be this. How can I say that? Let's put in the first position. This is the first position, right? First term. So for n equal to 1, means the first term, what will be the value? Twice n minus 1 will be 2 into 1 minus 1, that is 2 minus 1, which is 1. So it matches. For this, for n equal to 2, what do we get? 2 into 2 minus 1, which is 4 minus 1, that is 3. So it matches as well. For the third term, n equal to 3, we have 2 into 3 minus 1, which is 6 minus 1, that is 5. So it matches as well. It will keep on matching. So that means we have a general term twice n minus 1 to define this series. So whichever term you want to find, you can just put that value. Suppose the 5th term, the 6th term, or the 10th term you want to find, the 100th term you want to find, just put the value in place of n and you will get the what value it will have at that position. Okay, so you can find the specific term that you want to find from the given series. All you need to do is need to find the general term for this series. So I hope you understood the general term. Let's take one more example just to clarify your things out. Let's see, we have something like 1, 4, 9, 16, 25, 36 and so on up to n. Okay. So in this, what is the general term for this? If you look carefully, this is the first term. So the value of n here is 1 for this. So you can write, if I write this as n square, that will be 1 square, which is 1. Now let's move on to this. Here n is equal to 2. So if I write n square, it is 2 square, which becomes 4. So it matches. Now we move on to this. Here n is equal to 3. So if I write n square, it becomes 3 square, that is 9. Here it is 4 square, that is 16. This is 5 square, 6 square, and this will be n square. That means the general term for this series is n square. You put any value in n, whichever term you want to find, you can find it from here. This is 1 square, 2 square, 3, 4, 5, 6 square, 7 square, 8 square. It will keep on going till the nth term. So hope you understood what is general term, how to find a general term. You need to find a relation between every number given in the series. That's how you can find a general term. And once you find a general term, what is the need to find a general term? Once you find a general term, even if you don't know what is the next part of the series, you can find any term you want from the general term. Just put the position, which term you want, 6th, 7th, 8th, 9th, 100, 1000, 2000, 1 lakh, whatever term you want to find, just put the value in place of this variable and you will find the term out there. So that's how you find the general term. Now in case of series, there are two types of sequences or series. One is the infinite and one is the finite. Now let me give you two examples. Suppose I write 1, 2, 3, 4, 5, 6, 7, done. And I write one more. This signifies a finite series. Finite series means one that has an end. Infinite series means something that has no end. So based on what sort of question you get, you will be able to solve accordingly. Now again I will say finite series means the number of terms in a series is finite, means you can count the number of terms. How many terms are here? 1, 2, 3, 4, 5, 6, 7 terms are here. In this case, in infinite series, the number of terms are uncountable. So you don't know where it will end. So as a result, this is an infinite series. Okay. So now you need to know one new symbol that we will have called the summation. Summation. Summation symbol is this. It's a Greek alphabet. So we use summation. Summation means to add. Keep adding. Now let me write one thing. But what do we mean by whatever symbol? Let me write here n, and I'll write here n equal to 1 to 5. What does this symbol mean? This means that n is the general term for a sequence. Okay. So n is the general term for a sequence, and the value of n will range from 1 to 5. So this can be written as from 1. So the lowest term is 1. This is the lower limit, this is the upper limit. So we have to find summation of n, means we have to keep on adding n from 1 to 5. So first term will be, in case of n, we will add 1, then summation means adding. Second term is 2, then 3, then 4, then 5. This is the meaning of summation of n, and the answer you get here is 5 and 5, 15. Okay, let me try another one. Here let me write n equal to 1 to 5 again, and this time let the general term be twice n plus 1. Okay, what does this mean? So in this case, again in place of n we will write from 1 to 5, and we will keep on adding each term. So the first term will be 2 into 1 plus 1. This is the first term for n equal to 1. Then we will add it to for the second term, that is 2 into 2 plus 1. Then we will add it to 2 into 3 plus 1. Then we will add it to 2 into 4 plus 1 plus 2 into 5 plus 1, and we will end it here because the upper limit is 5. This is from where it starts, this is up to which it goes, means it ends here. So then you can find the value. It will be 3 plus 5 plus 7 plus 9 plus 11. So it is 20, 27, 32, 35. Okay, so that's how you find summation of any given general term. So earlier we knew how to get the general term, we got to know how to know general term, and now we will see how to add general terms, that is by using the symbol summation. So this thing, if you want to write in short, you can write it in this way. Okay, this is a very concise way of writing any summation, sum of different terms. That's how we do it. Okay, so I hope you understood this part. Now let's start with the exercise. So we will start with exercise 6.1 and see what we have there. So the first thing you need to find is, if you look into your book, the question number 1, it is given that write the first 7 terms of the given sequences given below. So they have given a sequence, they have given a general term. Okay, whatever we are going to write now is the general term, and you have to find the first 7 terms. So let me do number 3 because it is a bit different. If you understand number 3, you can do the others as well. So let me do number 3, and in 3 it is given minus 1 to the power n and 3n. This is the general term. Now from here you need to find the first 7 terms. So first 7 terms is, n is the variable, n will show us the number of term. So for n equal to 1, we have minus 1 to the power n into thrice n, which is equal to minus 1 to the power 1 into 3 into 1, which is minus 1 into 3, which is minus 3. So that's how you find first term. Second term will be for n equal to 2. Okay, I forgot to write. First term is this. For n equal to 2, the second term will be minus 1 square into 3 into 2. So it is 1 into 6, which is 6. Then you can write for n equal to 3, the third term will be minus 1 whole cube, 3 into 3, that is minus 1 into 9, which is minus 9, and so on. You can go on up to n equal to 7. So you find for n equal to 4, what you will get? The fourth term. Then for n equal to 5, you can get the fifth term, and n equal to 6, you can get the sixth term, and for n equal to 7, you can get the seventh term. So what you need to do, whatever question is given here, you will be given one variable, and all the variables given in this book are all n. So just put the values from 1 to 7. The first 7 terms means 1 means the first term, 2 second term, 3 is the third term, 4th, and so on. So you put the value of 1, 2, 3, 4, 5, 6, 7 in place of n, and you will get all the terms. So that's how you find the first 7 terms. Here we have found the first, second, and third term. 4th, 5th, 6th, 7th, you can do it yourself. I hope you have got the idea. A very simple sum. So question number 1, all of the sums go in the same way. So you can easily do it. Okay, now let's move on to question number 2. And in question number 2, you have to actually find the general term. They've given us a sequence, you have to find a general term, just like we did before. Let's try. So let's try question number 2, and in question number 2 we are given, let's try number 1. We have we have 1, 2, 4, 8, 16, dot dot dot. So what do we have here? We have, see, if you look into the sequence, just for your brief idea what you can do before you start doing the sum, you can get an idea by looking at the sequence as well. Okay, so if you look here, these are all squares, or these are all powers of 2. See, this is 2 to the power 0, this is 2 to the power 1, this is 2 square, this is 2 cube, this is 2 to the power 4, and it will go on like 2 to the power 5, 2 to the power 6, and then up to 2 to the power n. So for the first term, which now you need to, before you get to the general term, you need to find out which part is changing. The changing part will become the variable and the remaining will stay the constant. So here 2 is constant everywhere. So the general term 2 will remain constant. What is changing? The power is changing from 0, 1, 2, 3, 4, 5, 6. So in the first term, that is first term, the power is 1. So for n equal to 1, for the first term, the power remains 0. So if I write the general term as 2 to the power n, will it work? Check it out. N means first term. So for n equal to 1, when n is the nth term, so for n equal to 1, if I want to find the first term, for n equal to 1, 2 to the power 1 will be 2. So is it the first term? No, the first term is 1. That means if I subtract 1 from this, what will happen? For n equal to 1, the power will be 2 to the power 1 minus 1, that is 2 to the power 0, which becomes 1. Now let's check the others. For n equal to 2, for the second term, 2 to the power 2 minus 1, because this is general term, 2 minus 1 will become 2 to the power 1, which is 2. This is our second term. For third term, n equal to 3, it becomes 2 to the power 3 minus 1, which is 2 square, it becomes 4. So you can see it is matching. So that means our general term should be 2 to the power n minus 1. Now how should you proceed with the sum? How should you write it? Once you get the idea of how these things are working out, what is actually the general term, you can go on like this. You can write here, 1 can be written as 2 to the power 1 minus 1. 2 can be written as 2 to the power 2 minus 1. 4 can be written as 2 to the power 3 minus 1. 8 can be written as 2 to the power 4 minus 1. 16 can be written as 2 to the power 5 minus 1, and so on. So that means this 2, 1, 2, 1, these are constant. What is changing is this one. For first term it is 1, for second term it is 2, third term 3, fourth term 4, fifth term 5. Therefore, the general term will be 2 to the power. Which one is changing? This is changing, n minus 1. This is the general term. Hope you understood how to find out. First, get an idea by looking into the series, then you proceed with the sum this way. Let's try one more. Let us do question number 6. So in question number 6 we have a plus d, a plus 2d, a plus 3d, and it goes on. So how do we do this? Another very simple one. So if you check here, for the first term it is a. That means this d term is not even present. So you can write this as a plus 0 into d. This can be written as a plus 1 into d. This is a plus 2 into d. This is a plus 3 into d. This is the first term. So this a and d are actually constant. They are not changing. What is changing is this number. This is changing from 0, 1, 2, 3. Right? So for the first term it is 0. So when n is equal to 1, the value of this is 0. That means we cannot write it as a plus nd, because then the first term will become a plus d. For n equal to 1, this is for n equal to 1, first term will become a plus d. But is the first term a plus d? No, the first term is a, second term is a plus d. That means in the first case we must get this value as 0 into d, right, for the first term, this one, because there is no d. 0 into d means all I can do is a plus 1 minus 1 into d. 1 minus 1 becomes 0, so we get a. So this becomes a for the first term. For the second term we have a plus d. This can be written as a plus 2 minus 1 into d. Second term, a plus 2d can be written as a plus 3 minus 1 into d. third term. Okay, are you getting the idea? So that's how you proceed. So now how do you write? You can write it as here. A can be written as a plus 1 minus 1 into d. A plus d can be written as a plus 2 minus 1 into d. A plus twice d can be written as a plus 3 minus 1 into d. A plus thrice d can be written as a plus 4 minus 1 into d. So what you need to do, the basic idea is to get the numbers 1, 2, 3, 4 in serial order in the given sequence. So see, for the first term it is 1, for second term it is 2, third term it is 3, fourth term it is 4. So once you get, for the first term you get the number 1 which is changing into 2, converting into 3, then into 4. That means we are getting the pattern here. All the other numbers are constant. A is constant, 1 is constant, d is constant. Only this part is changing from 1, 2, 3, 4. As the number of terms are increasing, this part is increasing in a proportional manner. So therefore the general term will be a plus, this will be for the nth term, this will become n minus 1 into d. So I hope you understood this part as well. So we are done with question number 2. Let's move on to question number 3. So in question number 3 we have to find the summation. So we understood the symbol of summation. Now let's find out the value. So let me try question number 5 because it seems a bit tough, although it is not that tough. Let's try question number 5. It is given summation of n equal to 1 to 5 and the minus 1 to the power n into twice n. This is what we need to find. Okay. So what does this mean? Summation, as I have told you, summation means sum. So we will put the values of n as 1, 2, 3, 4 and 5. We will get 5 terms and we will add all of those. So this will be written as, this can be written as minus 1 to the power, first term is 1 into 2 to the power 1. This is one term. We will add these two, minus 1 to the power 2, second term, 2 into 2. In places of n, we will keep on putting 1, then 2, now we will put 3, then we will put minus 1 to the power 4 into 2 into 4, and lastly it will be minus 1 to the power 5 into 2 into 5. So it will be minus 1 to 2 is 2, minus 1 square is 1, 2 2s are 4, then we will have this will be minus 2, I am sorry, because minus 1 is there. Here it will be minus 1 cube means minus 1, 2 3 is 6, so it will be minus 6 plus minus 1 to the power 4 is even power, so it will be 1, 2 4s are 8, and minus 1 to the power 5 is again minus 1, 2 5s are 10. So what value do we get? We have 12 here, 16, 18, so it will be minus 6. So that's how you solve. You keep on writing the same term again and again, change the value of n as according to the term. What is the number of the term? If it is the first term, then put 1, second term 2, third term 3, fourth term 4, fifth term 5, whatever term you have, put that value in place of n and then sum them up, because it is the summation, means addition. So we'll sum them up and we'll get the value. So that's all with number 3. Now let's move on to question number 4. These are all easy sums, very easy exercise. You should try this yourself. We'll get into details in exercise 6.2. So again, in question number 4, they have given the general term here. Let's take number 1 itself. It is given un is equal to n into n plus 1 into twice n plus 1 by 6. And they have asked you to find the 5th and the 6th term. So un means the nth term. Nth term is this. Then therefore the 5th term means u5. Obviously u5 will be the 5th term. So in place of all the n's, put 5. 5 plus 1, 2 into 5 plus 1 by 6. So we have 5 into 6 into 11 by 6. So it is 55. This is the 5th term. Now we need to find the 6th term as well, 5th and 6th. So 6th term will be 6 into 6 plus 1 into 2 into 6 plus 1 by 6. So 6 will cancel out, it will be 7 into 13, that is 91. Very easy. Put the value of n in the as 5 and 6, because 5 means the 5th term, 6 means the 7th term. If you are given find the 11th term, then you will write, if you are to find 11th term, you will write u11 equal to in place of n you will write 11, 11 plus 1, 11 plus 2 into 11 plus 1 by 6, and you will find the answer. So hope you understood this part as well. Moving on to question number 5, another easy sum. So let's try question number 5, and here they have given it like this. They have given un they've given a general term un. This is question number 5. Un is given as, it will be 0 if n is odd, it will be -1 if n is even. Okay, so un's value will be this and this. So you have to find u16 and u25. Means 16th and 25th term you have to find. So u16 will be what? If n is even, the answer is -1. If n is odd, answer is 0. Now n is 16 here. 16 is even, so answer will be -1. And for u25, 25 is odd, so answer will be 0. Done. Question number 5 is done. Very simple. It's like childish. So now let's move on to question number 6. Here you have to find, you have to express the given sequence as a summation. As a summation. So if you have to express it as summation, you have to find the general term. Once you find the general term, then you can write the summation. So what series is given? Let's check. 2, 4, 6, 8, 10 and 11. It is given 2 plus 4 plus 6 plus 8 plus 10 plus 12, right? Yeah, this is what is given. So from here you can easily say this is 2 into 1, this is 2 into 2, 2 into 3, 2 into 4, 2 into 5, 2 into 6. So the general term, if for nth term it will be 2 into n. So twice n is the general term, right? So let's write it here. So in this case, since you have to find the summation, you can write it directly that here general term will be equal to twice n. For n you put n equal to 1, it is 2. N into n, when n is equal to 2 you get 4, if n is equal to 3 you get 6, n equal to 4 you get 8 and so on. So therefore what we need to find is we have to express with the symbol z. So therefore 2 plus 4 plus 6 plus 8 plus 10 plus 12 can be written as summation of twice n, and n will start from 1. Minimum value is 1. What is the maximum value? Means how many terms are there? 1, 2, 3, 4, 5, 6 terms are there. So it will be from 1 to 6. So you put the value of n equal to 1, you will get 2, and once you put the value of 6, means 1, 2, 3, 4, 5, 6. Once you put the value of 6, you will get 12. So that's how it works. Okay, I hope you understood this one. There are 4 more. So you need to find the general term. You have learned how to find general term. First you find the general term. Once you get that, you put summation, and this value, these two values will depend on the number of terms. So obviously it will start from 1 because you have a first term, and then you have a last term. So you have to count the number of terms here. So here we have 6 terms. So the upper limit will be 6. So lower limit will be 1. So that's how we do it. And now let's move on to question number 7, which is the last. So in question number 7, they have given us the value of u1 and un, and you have to find the first 4 terms. The first term is given, you have to find the first 4 terms of this series or sequence. So let's try something of question number 5. Let's try question number 5. Here it is given u1 equal to 3, u2 equal to 2, and un is equal to half of un minus 1 plus un minus 2. So we have to find the first 4 terms, but here u1 means the first term it is given, u2 means the second term it is given. So we have to find third term and fourth term. So let's find third term. Therefore u3 will be equal to what? So this is the general term. So let's put it u half, u into n is 3. So 3 minus 1 plus u into 3 minus 2, right? So again half. u3 minus 2, 1 is u2, this is u1, half. What is u2? u2's value is given as 2, u1's value is given as 3. So it is 5 by 2, or you can write 2.5. So that is how you solve. Very easy. This exercise is actually extremely easy, and the chapter is easy. It is not like the sequence is very tough. You have few known 2 or 3 formulae that you have to use, and you will get the solutions easily. So hope you understood how we did this. Hope you understood how we did the whole exercise. Very simple exercise. That's why I completed it today in this short video. So we'll move on to exercise 6.2 in our next video. So hope you understood this one, and until next time, cheers.